Next up is question 3. It says you wander slowly down a circular staircase from the top of a tower with x, y, and z in feet, and the origin at the base of the tower. Your position t minutes from the start is given by the vector function r of t, which is equal to 10 cosine t, comma 10 sine t, comma 90 minus 5t. All right, now before we jump into part A, let's go ahead and highlight a few things about this curve that you're walking along. So first note that the I component and the j components satisfy the equation x squared plus y squared is equal to 100. Okay, and that just follows from the Pythagorean identity. Okay, so that implies that the curve that you're walking along lies on the cylinder with the equation x squared plus y squared is equal to 100. Okay, so this is the cylinder of radius 10, and its axis is the z-axis. Okay, so as we let t increase, you're going to be moving along points on this cylinder. Now, if you were to project the curve that you're walking along onto the xy plane, okay, what will you see? Well, these components, the I and the j components, they describe circular motion along this base circle of radius 10 centered at the origin. So that implies, right, that as t increases, you're going to be wrapping around this cylinder. Okay, what's going on with your z coordinate? Well, that's a decreasing linear function. Okay, so as you let t increase, you'll wrap around and your height will decrease at a steady rate. So putting that all together, okay, your path will look something like this, right? You're going to start up here at the top of the tower when t is 0, and note here that is a height of 90 feet, and then you let t increase, so you're going to start winding down along this green path along this circular helix curve, right? That's pretty similar to the other circular helix examples we've seen in the last couple videos. All right, cool. So let's now go ahead and look at part A. It says, how tall is the tower? Well, since we're told we start from the top of the tower and the origin is at the base of the tower, okay, that implies that the height of the tower is simply the z-coordinate when t is 0, right? Because you're going to reach the bottom of the tower when you hit the xy plane, right, which is going to happen, say, somewhere over here. And since you start from the top, right, that initial height is the height of the tower. So z of 0, that's just 90 feet, so that's the height of the tower. How about B? When will you reach the bottom of the tower? That's going to happen, again, when you reach the xy plane. So that's when z, which is 90 minus 5t, is 0. So that'll happen 18 minutes after you start walking. How about part C? It says compute your speed at time t. Okay, well, for that, you want to first find the velocity vector. And so to find the velocity vector, you want to just differentiate the position vector component-wise. So you'll get negative 10 sine t, comma 10 cosine t, comma negative 5. The speed then is the magnitude of this velocity vector. So that's the square root of the sum of the squares of the components of the velocity vector. So we have negative 10 sine t squared plus 10 cosine t squared plus negative 5 squared. Now, the sum of these first two terms, that's going to be 100 from the Pythagorean identity. And then you're going to get a 25 there. So we're looking at the square root of 125, which simplifies to 5 root 5. And the units here will be feet per minute, because the spatial variables, x, y, and z, those are in feet, and the time's in minutes. Okay, so you're walking, in fact, with a constant speed, okay, as you wind down this staircase, and that speed is 5 root 5 feet per minute. All right, cool. How about part D? Compute your acceleration at time t. What do you notice about the direction of the acceleration vector? Okay, so to find the acceleration, right, you want to differentiate the velocity vector component-wise. So we get negative 10 cosine t and negative 10 sine t. And then for the k component, you just get 0 because you're differentiating a constant. Okay, so let's first think about projecting your path onto the xy plane. Okay, as we have already noted, the I and the j components are just describing circular motion around this base circle of radius 10 centered at the origin. Okay, so now what would the direction of the acceleration be right, if I'm looking at the projection on the xy plane? Well, notice the I and the j components of the acceleration vector are the same as the I and j components of the position vector, except we have negatives, right, in front. So just like we saw in the very first question on this worksheet, right, our acceleration vector will point directly towards the center of this base circle, right, when you project everything onto the xy plane. Right now, if we lift up to R3, if we actually look at the acceleration vector along the path, okay, well, since the k component of your acceleration vector is 0, that implies that the acceleration is horizontal, right? So in other words, it's parallel to the xy plane, right? And from what we saw over here, right, projecting onto the xy plane, right, the acceleration vector points directly towards the center of the base circle. When you lift up, right, to your path in R3, since the acceleration vector is just always horizontal, right, 0k component, that just implies that acceleration will always point directly towards the z-axis. Okay, so as you move down this staircase, okay, your acceleration always points directly towards the z-axis. Very good. All right, so now let's look at part E. It says find the total distance you travel as you move from the top of the tower to the bottom. Okay, so I'm going to make a little space here. So to find the distance traveled, right, we really want to find the length of the arc from your starting point up here when t is 0 to where you wind up hitting the xy plane at the base of the tower, and that happens when t is 18. So we want to find the arc length as t varies from 0 to 18, and to do that, like we saw in the last video, we want to integrate the speed, right? And we found in part C that you're actually moving with a constant speed, so we're actually just integrating the constant 5 root 5 over the interval from 0 to 18, and this comes out to be 90 times the square root of 5, and that would be feet, right, because we're measuring the distance traveled. All right, and then lastly, for part F, it says, at what time have you traveled 100 feet? Okay, so that's pretty much the same question we're being asked in part F, except now, right, we're told that the distance traveled is 100 feet. We're not told, right, the time interval. So I'll integrate from 0 up to some number a, and I'm going to set this arc length integral equal to my distance traveled, which is 100 feet, right? So go ahead and integrate. This turned out to just be 5 root 5 times this unknown upper limit of integration a, and so if 5 root 5a is 100, then a itself must be 100 over 5 root 5, which simplifies to 20 over root 5, and that would be minutes, right, because a here is a time. Cool. All right, well, that does it for this question. I'll see you in the next video. Thanks so much.